Hello, everyone. This is Miss Reese. I'm going to be going over the Unit 2 Algebra 1 test. I'm taking it as if I'm a student. I have a few things open. I have my Desmos scientific calculator, or next to me, you could have your regular scientific calculator, and I also have my toolkit that's filled in next to me. So these are my things that I'm using during the test. So I'm going to go ahead and click Start the assignment, and you can also see how I'm modeling answering these questions. So if we look here, we want to determine on the first question if each of these represents a function. So I'm going to say, well, let me look back at my toolkit. All right, so function, we know that in order for something to be a function, the vertical line test, if we can draw a vertical line that crosses the graph more than once, it is a function. So I just took that from the top part of my toolkit here. So now, if we can draw a vertical line that's going through this, I'm just going to use my scratch pad so you can kind of see some of the lines that I'm drawing in. So if I were to draw in a vertical line pretty much anywhere on this graph, it is not going to intersect the graph more than once. So that is a function. I'll check my answers later in just a moment. Okay, we've got a vertical line drawn here that crosses the graph 2 times. That is not a function. This vertical line will also cross the graph twice, so that's not a function. Any vertical line drawn here will not intersect in more than one place. That is a function. And then lastly, this parabola here, it will not intersect more than once. It is a function. So I'll go ahead and go off of the scratch pad, and then I'll just go ahead and answer them. So we said this was a function. We said not a function. Not a function, doesn't pass the vertical line test, is a function, and is a function. All right, on to our next question. Okay, let's see if I can make this zoom in just a little bit. So now what we want to know, which of these tables is not a function? Let's see. I do want to open up my scratch pad just so I can kind of show you some of the points here. Okay, so what we're looking at is we remember that in order to be a function, let's see, to be a function, a relation must not have multiple outputs for one input. Okay, so let's go back to our test. So we're looking here, all of my table 1, the input of 3, 5, 7, 9, 11, 13. Okay, those are all different inputs, so we're good there. On the next table, we do have the same input 3 becoming 6. Let me make that a little smaller. And we also have the input 3 again, but it's giving the same output. So that's okay. This is fine. This one's fine as well, though, as a function. If we look at the next one, we have 2, 8, 14, 20, 26, 32. Okay, so none of the x values repeat, so we don't even really need to check. This is also okay. So then let's look at our last one here. We have an input of 1 giving an output of -2. And then again, we have an input of 1, but this time giving an output of 16. So that is not a function. Oops, not. So that would be table 4, which is not a function. All right. So now I'll go off the scratch pad and we'll put in our answer as we would model it. Okay, then we'll go to our next question. We want to look at the story. The story is about me. So the graph shows Miss Reese, my run last night, and we want to reorder the list to match the graph. So if I look here, it looks like I'm maybe leaving from a distance from home. So I'm leaving home, and then I'm stopping at some point. Here I'm going really fast, and then it looks like I'm kind of turning back around. So let's see. We know our second part of my graph is stopping. So I'm going to move that over to the stop section. Let's see. Walked away, going away from her home. So I think this would maybe be first because I'm walking in that first section. It doesn't look like it's too steep, so it doesn't look like it's too fast. Let's see, ran farther away from home. So we talked about this third section here looks like a really steep, and it is going away from the home, so that would be third. And then let's see, we are getting closer, walking closer to home. So that would probably be this next section, which is not as steep. And then even steeper here would be running back to home. So we'll put that in the last part here. And then if you want to remember and look at your toolkit at the bottom, you can kind of see the different parts in the graph that we're describing here that you can kind of help yourself match up. Like, oh, the horizontal line, that means we're not moving. Okay. And then what are each of these other sections? What does it look like when it's steeper? So always look back at that toolkit for some help. All right, so that one's answered. We'll go to our next question. So the first thing, it says the set of all possible inputs is called the, well, let's go back to our toolkit. Set of all possible inputs. I'm gonna look at the top. The domain is the set of all possible inputs. So I'm just gonna type that in. And then it also says here, the range is the set of all possible outputs. So we've got here domain and range. And so for this graph, we're looking for the domain. And let's remind ourselves to find the domain given a continuous graph. We want to scan the graph, for, the x-axis. So we're going to kind of look from left to right, the x-axis. So if we look at our graph here, the domain, from left to right, well, I've got an arrow going to the left forever, and I've got an arrow going to the right forever in both directions. So this is all real numbers. So I'm going to click on all real numbers here. And what is the range? So range is the y values. So we want to scan the y-axis. So what's the highest point on the y and what's the lowest point on the y? Well, I'm noticing here the highest point on my y, and maybe I'll just open up my scratch pad. Okay. Whoops. Oh, okay. Well, there we go. So we've got here the highest point of the y is at 3. The lowest point of the y is at 1. So that means it's between 1 and 3. So if I go to my graph and I know it's on the y-axis, I would say, okay, it's between 1 and 3. So I'm going to select question D. Oops, here we go, D. Great. Go next. Here we've got our 4 different types of slopes. Let's look back at our toolkit. And we've got our positive, negative, undefined, which is a vertical, and horizontal, which is 0. So I'm going to use that as a guide to help me decide the 4 types of slopes. So undefined, that's a vertical line. So I'm going to pick the vertical line, drag it here. Positive slope up to the right, drag that here. And we've got a negative slope down to the right. And our 0 slope was that horizontal line. So here we've got that matched in here. Okay, we'll go on to our next question. Here we're going to find the slope for our scratch pad. Remember, slope is vertical change 1, 2, 3, 4, 5, 6, and 4. 1, 2, 3, 4. So remember, slope is vertical change over horizontal change. I'm looking back at my toolkit. Here's an example, the 7/3. And it looks like it's positive. So this one is also positive. And it is change in y over change in x. So up and down vertical, which was 6 over 4. And we always want to write our solution in simplest form. So that's going to be 3 over 2. So now when I go out of my scratch pad, I can go ahead and type in the answer 3 over 2. And I'm going to do a fraction here. And I'm going to put a 3 on top and a 2 in the denominator. Simplest form, and it's positive. I'm going to the next question. This slope here, let's check our vertical and horizontal change. We've got 1, 2, 3, 4, 5, 6, 7, 8, and 4 to the right. We also know that this is a negative slope. It's going downhill, so negative 8 over 4. And we need to simplify this. Well, negative 8 divided by 4 is going to simplify to negative 2. So I'm just going to put this in as a negative 2. And you always want to have slopes in simplest form. So I'll type this in as a negative 2. Okay, we're going to find the slope between these 2 points, and we got to use our scratch pad this time to show our work. And let me make it a little smaller there. Oh, let's pick another new fun color. Let's do a blue. Okay, so remember our slope formula, m y2 minus y1 divided by x2 minus x1. And if we forgot that formula, well, let's just look back at our toolkit. Here's our slope formula at the top of this page and a few example problems as well. Okay, so now all we need to do, I'm going to label this point x1, y1, x2, y2. So now we can say, okay, the negative 9, now we're going to subtract from that 3. Negative 9 minus 3. And then 3, we're going to subtract from that a negative 1. So as long as you have all of your work here, now if you'd like, you can go ahead and simplify that in the Desmos calculator. We'll do it together, and then I'll show you how to do that on the calculator. So we have negative 12, and then we're going to divide that. This is really like 3 plus 1 minus a negative is plus, and this is going to simplify to negative 3. Now, as long as you have this step here, and then you're getting your answer, I'm okay with you putting it into Desmos. So in Desmos, what did we have? We had negative 9 minus 3, negative 9 minus 3, and then we're subtracting from that 3 minus negative 1. And our solution is going to be negative 3, and that's what we got here. All right, so we can turn off the scratch pad and just put in our slope of negative 3. So we're just putting the number. We don't need to put m equals or anything, just the number here. Okay, we're going to do one more slope question. Okay. And I'll close out of that. All right, so we have our y2, which is 1 minus 10, or y1, 1 minus 10, divided by here 2 minus 8. And you can put that into Desmos if you want. I'm not going to this time, but we have 1 minus 9, I'm sorry, 1 minus 10, which is negative 9. And then we have 2 minus 8, which is negative 6. Now we have a negative divided by negative, which would be positive. And then we need to simplify it as well. So I can divide by 3 here, divide by 3 here, and I'm going to end up with a 3 and 2, 3 halves. So my slope is 3 over 2 in simplest form. Oops, go out of the scratch pad. And I want it to be a fraction, so 3 and 2 for the slope. Okay, now we have our slope and our y-intercept. So remember, in slope-intercept form, let's look here at our graph. Slope m is the slope, and 0 comma b is our y-intercept. So we're just looking for the m and the b, kind of just like we did in these examples. So you can look at this. In number 3, we have y equals 2/5 x plus 2. Our b was 2, and our m was 2/5, the number in front of x. So we're going to do the same thing here. So our slope, we'll go off the scratch pad. Our slope would just be the number in front of x, the mx plus b. So it would be a negative 1/5. 1/5. And I can just type that in as a fraction. I don't even have to use this number pad here. We just use the division symbol. And then my y-intercept is this +4 or just +4. So I just type in a 4 here. Oh, I'll have to click that. I don't know why I wasn't let. No, delete. There we go, 4. Next question. Create an equation. We have a slope of negative 4. Okay, so that's the m, and our y-intercept is 0, 3. So y equals mx plus b. So we would say y equals negative 4x plus 3 plus b plus 3. So we can write it like that. That's fine. Yeah, I don't really see any other. And then this is not going to be an x. This is actually multiplication. So I noticed some people put that in as a multiplication, and they use that as a variable. So we've got here y equals negative 4x plus 3. Great. We'll create one more equation. We've got y equals, we have our slope 7/8, so 7 divided by 8. And then I want to do an arrow to go out of the fraction there so I can put the x after it. And then our y-intercept, our b, is negative 12, so I'll just put minus 12. Now we're going to practice some graphing. So scratch pad, just a little reminder. Our slope is -3/5, which means it's going down to the right. So down 3, right 5, or I can do the opposite of down and right. And our B, whoops, B is -4. So we have a point at 0, -4. So that's where we always want to start the graph on the y-axis. So we have a point at 0, -4, and our slope is -3/5. Okay. So now we will go out of the scratch pad and actually go ahead and graph it. I will put, for the line tool, -4. And then from this point, I'm going to go down 3 to the right, 3, 4, 5. There you go. And it's not making a line, but now I got a line here. Okay, good. I've got my 2 points, A and B, and we have our line graphed. Now we have a slope of 6, and we have a y-intercept of 7. And if I wanted to, I could still, kind of look back at these example graphs here. Okay, we want to write down maybe our m, we want to write down our b. Okay, we know we've got a positive. So let's see here. Let's just write out our m equals 6, which is like 6 over 1. It's the same thing. It's a positive slope. And our b is 7, so that means we have a point to start at 0, 7. Okay, so we'll go ahead and graph that. Let's put our line in. We put our first point at 7. And then if I want to go up 6 to the right, I can't. I'm going to go off the graph. So opposite of up and right would be down and left. So I'm going to go down 1, 2, 3, 4, 5, 6, and left 1. And there we've got our line, y equals 6x plus 7. Here we've got a y equals -2x. So I'm actually going to look back at my toolkit. And this is similar to question 8. So there's nothing being added after this -4x. So we assume that there's a 0 added. Okay, so and then our slope in this example 8 was -4, but in this problem here, in our scratch pad, so we've got our b is 0. You can almost imagine there's a plus 0 here. And then your m is -2. And it's like -2 over 1. So it's down and to the right. So let's go off the scratch pad. We'll get our line, put a first point at 0, down to right 1. There we've got our line. Y equals 7. All right, let's look back at our toolkit. What is a y equals graph? Well, let's go to this page here with horizontal and vertical lines. So we have here a vertical line is written in the form of x equals a. Okay, so that's not what we're looking for, but what we're looking for is a horizontal line. A horizontal line is written in the form of y equals a. Okay, so basically what I want to do is graph the y-intercept and then draw a horizontal line. So we'll go back here. We are going to graph the y-intercept. So the y-intercept is at 0, 7. All right. And then I just want to draw a horizontal line through that. And technically the point, there is another point on that line. So I'm going to put a point at 7. And then the other point could be basically anywhere along this horizontal. And that's because y is always going to be 7 anywhere along this line. 0, 7, 1, 7, 2, 7, 3, 7, so forth. -8, 7. So I could put the other point really anywhere I wanted. And I could put this point A, it doesn't have to be at that point necessarily. It would still be the correct graph if I moved the point over here. But that's just a guide of where we usually like to start the graph. Okay, we've got next question. I bet this is going to be a vertical line. So looking back here, we have a vertical line is written in the form of x equals a. All right, so now we want to put and write out our x-intercept first. So if x is -6, our x-intercept is going to be -6, 0. So we're going to put a point there, and we're going to draw a completely vertical line through that. So I'll start with my point at -6. Anywhere along the vertical line will be my other point that I'm graphing. There we go. All right, now we've got some converting for the next question. So that's back on our toolkit. Let's see. Okay, so we're converting from a standard form to a slope intercept. So it looks like the first thing we're always doing is subtracting our x term on both sides. If you notice here, minus x, minus 2x, minus 4x, minus x. Okay, so we're going to rewrite this equation. We need to do our scratch pad work for this as well. Let me get maybe a purple this time. So I'm just going to rewrite my equation. We've got 3x plus 6y equals 12. So my first step, I am going to subtract an x on both sides. Okay, so let's subtract a 3x. Let's subtract a 3x. Now that was my first step. Now I want to kind of go back and we're going to rewrite our equation. 3x minus 3x is 0. So then we have a plus 6y, or just 6y equals, I like to write mx plus b first. So I would typically write the negative 3x, then plus 12. So it is in the form y equals mx plus b. Okay, so now my next step here, we'll go back to our blue. Next step would be dividing by the number in front of y, the coefficient, because I want this equation, instead of saying 6y, I want it to say y equals. So if I divide by 6 here, I'm going to want to do that for the other two parts as well. And I do like to put it a little fraction under both of these, to just a reminder to myself that I'm dividing both of those parts. So now I can write my equation. I'll write this here. 6y divided by 6 is y. Okay, good. I got it into y equals format. Negative 3 over 6. Well, that simplifies to negative 1/2. And if I didn't remember, I would say, let me go back to my Desmos scientific calculator. So negative 1 over 2x plus 12 divided by 6 is 2. So plus 2. All right, now I'm going to graph it. Our slope is negative 1/2. No, let me move down a little bit. And our b is 2. So I'll go off the scratch pad so I can graph it. So and I want to type my answer in here. So it was y equals negative 1/2 x plus 2. I want to type it in, that'll help me to remember when I'm graphing it. So put my first point at 2, my slope is negative 1/2. So down 1, right 2. Okay, and my last equation here, my scratch pad. All right. So we've got our equation, 7x minus 3y is equal to 6. So our first step to this, and I'll just use the same color, is subtracting the x term on both sides. That gives us negative 3y is equal to negative 7x plus 6. Then we're going to divide by the number in front of y, the coefficient, to all of our terms. Now when I rewrite my equation, we've got a negative 3y divided by negative 3. Whoops, that's just going to be a y. Negative 7 divided by negative 3 is just 7/3. We still have our x term there. And then 6 divided by negative 3 is negative 2. So we'll go ahead and type that in. So y equals 7 over 3x plus 2. And then I'm going to go ahead and graph it. Let me check my scratch pad. Was that the right equation? Oh, minus 2. Let me go back. I knew something wasn't right. Let's put our first point at negative 2. And then our slope is 7/3. So from that, I can go up 7 to the right 3. There we go. And I'm done with that question, and I will go ahead and submit. All right. Thank you for watching this video, and I hope that helped you in understanding any questions that you got wrong on this test.